In this lesson, we're going to be taking a look at circles and a special part of the circle called an arc. Let's begin with the different parts of a circle that do exist anyway. We have here line segment AB. Line segments that go completely across the circle through the center are called the diameter. So AB is a diameter. A line segment that goes from the center to one edge only is called a radius. So in this circle, PC is the radius. Plural for radius is radii, and that is spelled radii. Next, we have what's called a central angle. Angle APC has this angle measurement associated with it for the circle, and that is that central angle. So angle APC is the central angle. And last, but probably most important, is how do we name a circle? Because this circle has the center of P, we name it by that. So P is the center, and what we do is we call it circle P, with a circle emblem with the center noted. So we can talk about different circles that exist based on the centers that they show. Now, part of the circle, like I said, that we're going to be focusing on in this lesson, is called an arc. There is an arc on the circle from A to C. An arc is a portion of the outer rim of the circle, but not the full thing. And arcs can have measurements, and the measurement of the arc is equivalent to the measurement of that central angle. So we have arc AC, arc CB, we have arc AB as well, making up a semicircle or half of the circle. Any time that you see an arc, there are actually two different arcs present. So we have an arc between B and C that's very close, and we name it just by that. And then we have an arc that goes from B to C around the long way, and we would name it by the extra points that it passes through. So arc ABC BAC goes this way, whereas arc BC only moves this short clockwise direction. So we have a circle shown, and what we want to do is name as many parts as possible. We're going to start by naming the minor arcs. Now again, the minor arcs are those that fall under 180 degrees. So we would have arc SR, and the way we note that is with an arced symbol over the top of it. We would have arc SP, arc SQ, arc PQ, and arc QR. Anything else would be a major arc, meaning that it travels over 180 degrees. But next, let's find those major arcs. And to do this, we can use the minor arcs as a guide. Since we had an arc SR, we would have to have from S and R again, and we'll go around the opposite direction. So we'll call it SQR as an arc. Could have also named it SPR. We have arc SP, so we will have arc SRP. We had SQ, we'll have SRQ. We had arc PQ, so we will have arc PSQ going counterclockwise, and we have arc QR, so we'll call it arc QSR, going around counterclockwise again. And just a reminder, all of this is based off of the fact that these are in relation to circle A. So we get a little used to seeing that notation as well. So once we have these arcs, what can we do with them? Well, just like other items involving angles, we can do some arithmetic. So let's take a look at a postulate that talks. We have arc addition postulate 10.2, which tells us the measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs themselves. So if you have two arcs sitting side by side, just like if you have two adjacent angles, you would add the angles together, you add the measurements of those two arcs together as well in order to get the one major one. So from the diagram that we see, we want to try and find the measurement of all the arcs. Now to do this, we're going to use the angle measurements that are already given. For instance, angle PCR is given to us as 77 degrees. Well, that would mean that the measure of arc PR is 77 degrees as well, because the arc measurement is equivalent to the central angle measurement. And we know that the measure of arc QS is 28 degrees. PS, line segment PS, runs through the center of the circle at C, so that means that it is a diameter. That a diameter cuts the circle in half. We have 180 degrees. If we subtract this 77 degrees from the 180, that will tell us that the measure of arc RS is equal to 103 degrees, being the supplement of 77. By a similar notion, we can calculate that the measure of arc PQ is going to be the supplement of the 28 degrees, so that makes it 152 degrees in total. Then we can start working with different relationships that exist in here. If we get past those, we can start looking at major arcs or adjacent arcs. If I wanted the measure of arc RPQ, we'd be looking at that being arc RP and arc PQ. Well, when we add those together, we get 229 degrees as being the sum of the 77 degree arc here and the 152 degree arc here. And then we can start looking at others also. For instance, the measure of arc RSQ. I'm naming it by 3 points, even though it is only a minor arc. It would be the addition of arcs RS and SQ. RS is 103 degrees, SQ is 28, so when we put those together, we get 131 degrees. And we continue matching them up as such. But what else can we do once we have all these arcs put together? With our arcs, we also have the ability or capacity to find the measures of different arc lengths. The largest arc length is going to be the circumference of the circle. Now, Theorem 10.9 is the definition for the circumference of a circle, and it tells us the circumference of a circle is the product of pi and the diameter. You've probably seen this before, but C equals pi times diameter, or since the radius is half of a diameter, circumference equals 2 times pi times the radius, because 2 radii make up the diameter. We also have a term when dealing with circles that is concentric. Now, the word concentric means multiple circles that exist in the same plane, or coplanar circles, that have the same center. So if you were to take, this is going to be freehand, but if you were to take an outer circle and then put a second one inside of it, such as a washer for building products, or even if you want a donut, the outer edge of the donut and the inner edge of the donut are concentric circles because they do share the same center. Now, with our concentric circles, or any circles at all, and these arc measurements, we're going to be able to find the length of arcs. That brings us up to theorem 1010. The arc length theorem tells us the length of an arc is the product of the ratio of the measure of the arc in 360 and the circumference of the circle. Now, how this would appear in written form is we take the arc measurement, divide it by 360. That tells us what fraction of the circle we're looking at, and we multiply that by the circumference of the circle. So first we establish how much of the circle we want, and then we look beyond that. So in the circle that is shown here, circle O, we have arcs XY, which is a minor arc, and arc XPY, which is the major arc. Circle O has a radius of 15 centimeters, and what we want to do is find the length of arc XPY. So we're going to calculate this by saying length of arc XPY is equal to its arc measurement, which is 240 degrees out of 360, times the circumference. Now circumference again is 2 times pi times the radius, which in this case is 15 centimeters. And we're going to leave our answer in terms of pi. So 240 divided by 360 simplifies down into being 2/3. 2 times 15 for our circumference formula is 30. So we have 2/3 times 30 pi. 2/3 times 30 is simply 20. So we have 20 pi centimeters as being the length of the arc. So we can talk about arc measurements, we can talk about arc lengths, we can talk about major or minor arcs in order to finish everything out. So a lot of new vocabulary and a few new terms and postulates here. Make sure you have them down, because next we're going to take these arc lengths and start talking about the areas of the circles that they are kept in.